Good morning guys, and welcome to part 2 of today's worked exam answer videos. So I'm having a look at another practical question ahead of tomorrow's paper 3 exam, and in this question I'm having a think about RP10. Specifically the part of RP10 which is looking at recrystallization of an organic solid. This is often done in the context of aspirin, but won't always be. So in this question, we're not thinking about aspirin. You were given like an organic synthetic route at the top of the question, and the product of step 1, which I believe was a phenyl-based N-substituted amide. That's what we're trying to recrystallize here. So I guess the first thing is, don't always assume that it will be in relation to aspirin. So we need to be picking up on things like recrystallization as a clue that we are thinking about required practical 10. Now in this question we are not only giving the method of recrystallization, we're having in this question to explain why each of these steps are done, and this is potentially a worst case scenario for this practical or any of the practicals, because it's one thing to sort of know, well, first of all I'm going to dissolve the crude product in the minimum quantity of hot water. Great. And if you were to give a 6-mark answer for how you would recrystallize aspirin, for example, to purify it, then that would be more of a case of rote learning a stock answer to be able to then sort of regurgitate, if you will. And of course you can rote learn the what's going on and why, but that is going into a bit more detail. There's a bit more understanding that is required for that. So we'll go through why each of these steps are done, and then I also included a little bit on the kind of follow-up part, which is once we've recrystallized a solid, we can see how pure it is. In a couple of ways. We can do the melting point of the sample using melting point apparatus and see at what temperature it starts and finishes melting, and whether that is lower than the data book value and over a range, which would suggest it's quite impure, or is it bang on exactly what it should be, melting at one temperature, in which case it's pretty pure. We can also think about the crystals as well. The larger they are, the more needle-like they are, the whiter they are, the purer the solid in relation to aspirin. So thinking about this, product of step 1 was purified by recrystallization as follows. So first thing, we're going to dissolve the crude product, which is what we've made prior to purifying it. So again, in the case of aspirin, you would be adding your ethanoic anhydride to the benzene-based salicylic acid, and the aspirin that was made initially, that would be called the crude aspirin, so pre-purification. So we're dissolving that in the minimum quantity of hot water, and then the hot solution was filtered through a hot filter funnel into a conical flask. This filtration removed any insoluble impurities. So in other questions it might say, why do we filter it hot? And they've given us the answer here, it's to remove any insoluble impurities. Now I'll explain more when we get onto the explanation part as to why each of these things is required, so that you can really get a sense of what we're doing here and why we're doing it. The flask was left to cool to room temperature. The crystals that formed were filtered off using a Buckner funnel, and a clean cork was used to compress the crystals in the funnel. A little cold water was then poured through the crystals. After a few minutes, the crystals were removed from the funnel and weighed, and then they did the melting point apparatus for melting point determination on a small sample of those crystals. So the 4 things in bold are the things that we are having to explain. So first of all, dissolving the crude product in the minimum quantity of hot water. There's kind of 2 parts to this. One, the minimum quantity, and one, the hot water. If we're trying to dissolve something, using hot water is going to be more effective because solubility will increase as the temperature of the solvent increases. So that is to ensure that we've got as much of the product being dissolved as possible. But doing it in the minimum quantity means that we're going to generate a saturated solution, which is really important when it then comes to cooling the solution back down in terms of getting as much of the product to recrystallize. And with recrystallization, it is the getting the crystals back out of the solution that is the biggest cause of a low yield in these experiments. So it says actually here that we're leaving the flask to cool to room temperature, but again, as solubility decreases, as temperature decreases, the cooler we can get it, so by maybe putting it in an ice bath, the more crystals we will get back, which they may mention in other questions as well. Once we've dissolved the crude product in the minimum quantity of hot water, the product that we want to recrystallize is dissolved. So if we then filter it hot, anything that hasn't dissolved, our insoluble impurities, will be removed at that point, which is why we need to filter it hot, because if you were to pour your hot solution through a cold filter funnel, immediately the solution will cool down, and then some of the product that is dissolved will be not dissolved anymore. It will come out of the solution, and then it will be trapped in the filter paper, in the filter funnel, and we're going to lose a lot of our product. After cooling to room temperature, we're going to filter off using a Buckner funnel. So this is referring to filtration under reduced pressure, or vacuum filtration, or Buckner filtration. There's a few different words for the same thing, but it's where you have the side arm on the Buckner flask connected to the vacuum so that you create that suction, so that we can draw out all of the moisture from the crystals and get rid of as many impurities as possible. So the cold water is designed to, at that point, rinse off any soluble impurities. It needs to be cold at this point because we do not want the product to redissolve, because otherwise if your product is redissolving, it's going to go through the filter funnel, the Buckner filter, into the Buckner flask and be lost. So we need to have a solvent which is or rather which the solid is not very soluble in when cold, but very soluble when warm. So we need a big jump in solubility so that when it's warm, we've got as much of it dissolved in the first instance to get rid of the insoluble impurities. But then once we've cooled it down and we rinse with the cold solvent, we don't want any of the product to then redissolve. So we need it to be very insoluble when cold. This idea of pressing the crystals with the cork, that's going to encourage all of the moisture to be pulled through the crystals. If you think about having like a big lump of crystals and you just put the cold solvent sort of onto the top of them, that's then kind of going to run off the sides, and then the suction underneath will kind of pull all of the liquid off of the sides of our mound of crystals. But by pressing the crystals with a cork, we're allowing more air to go through the crystals, which will enable more of the moisture to be sucked out from sort of that inside that big chunk of crystals, which is also going to enable more of the solvent to pass through the individual crystals, which again will help to remove more of the impurities. So I would always recommend trying to understand something as much as you possibly can, but if not, because you're just thinking, I can't get my head around what's going on, which I totally understand, then we do need to memorise how we would recrystallise a solid, but then also know, particularly for RP10, why we are doing these different things. So everything I've just explained I'll write down, and I'll pause the video here and come back, and then we'll have a think about part C together. Okie dokie, so that's what I've written down for the reasons why we do these things. And for the first one, the minimum quantity of hot water, I've broken it down into why hot water and then why minimum volume. And like I say, if you're writing the method, you'll get 2 marks, one for minimum quantity, one for hot solvent. Here we're only going to get 1 mark per explanation, but in other questions that might be slightly different. So once we have got our small sample, we are going to figure out the melting point, and we are told that the melting point of the sample in part B was found to be slightly lower than a data book value. And I guess the first thing when we see that is we need to be thinking, right, well, it's therefore impure. So for example, aspirin melts at 136 degrees. If it started melting at 130, that would suggest impurities are present. It does then, however, in this question to go on to say, suggest the most likely impurity to have caused this low value, and also to suggest an improvement to the method so that a more accurate value for the melting point would be obtained. Now, if we have a look back at the method, if you had given this method as your answer in a question, you would not have got 6 marks out of the 6 that are often available. And the reason why is this final step. So once you have poured a little bit of cold water or cold solvent through the crystals, and you've allowed the suction to kind of draw as much of that out as possible, you can't just immediately weigh the crystals. You should be, first of all, drying the crystals, because there will still be some moisture on there from the cold solvent that you've just rinsed them in. And that's what's going on here. Because we haven't dried the crystals, the most likely impurity is going to be water that we've literally just rinsed the crystals with. And that water will be acting as an impurity, which is going to lower the melting point of our sample. And it was nice that they linked it into the method here so that we could go back and think, well, what in the method have we not done? And unlike with aspirin, we don't need to know sort of the exact solvent that needed to be added here. We don't need to know sort of what any likely impurities might be. We don't need to think about the reactants at all. So the only thing it could be that we know has been added that shouldn't be there at the end is the water. So suggest the most likely impurity, water, and suggest an improvement to the method. That would be to dry the crystals between sheets of filter paper prior to weighing. Now, of course, it might be that there are still some impurities present, and I have seen a question where they've asked you to calculate the yield of a recrystallized solid, and you get an answer that is greater than 100%. Now, of course, we can't have a yield that's greater than 100%, and therefore it means that the mass of product that we've measured isn't just product, it can't be. And again, that could be that there's some solvent present still, or it might be that we did not effectively remove all of the impurities, so impurities are contributing to the mass as well. Okay, this is a bit of a tricky practical. Any questions, please let me know. I'd also recommend that you're able to draw the vacuum filtration, Buttner filtration, filtration under reduced pressure apparatus, or at least be able to describe it. And also don't forget that within required practical 10 there's also the obtaining an organic liquid, which is the one where we tend to think about the separating funnel, and it might be that you are making, for example, cyclohexene and water from cyclohexanol, and the two products are immiscible, so you get the layers forming in your separating funnel, and you get rid of the layer of water, and then you're left with what you hope is your layer of cyclohexene. It may have some water in it though, so you add your drying agent to absorb the water, and all of that kind of thing. So don't forget that's a part of required practical 10 as well. Any questions, let me know, guys, and if I don't hear from you before tomorrow's exam, all the very best for the exam. Try keep an eye on time. Try make sure you're not rushing all the multiple choice at the end. If you are thinking about rushing the multiple choice at the end, try and just obviously whittle down the options as much as you possibly can with the time that you have. Don't leave them blank, obviously, because you're definitely not going to get them right if you leave them blank. And for the practicals, just try and make sure that you're thinking about kind of, so what if it says, why do we not do this? Because this will happen. So what if it does? Or so what if it doesn't? Just try and make sure you give enough detail in your answers. But all the very best for tomorrow, guys, and thank you so much for all of your support, on my videos for this exam season. I really appreciate it, and yeah, all the very best. Take care.